Today we're going to be studying algebra, which is going to be the concept that is going to appear on more questions on test day than in any other concept. We're going to start today by discussing a definition of variables. Variables are going to be the x's and y's in the equations that you see on test day. They're going to stand in for unknown values. Often on test day, a question will limit the acceptable values that you could use for a variable. So for example, a question may say x is a negative integer or y must be positive. When you see variables on test day, you want to remember that any single math operation that can be done with regular numbers can also be done with variables. So you can add, subtract, multiply, and divide those variables that you see in the equations. There are a couple of restrictions, which we will talk about as we go through our examples. Let's take a look at our first example. Question says, evaluate 3x squared minus 4x when x is equal to 2. What you're given here is an algebraic expression, and the question tells you to substitute in a numerical value for your variable, x. So we're going to substitute 2 for every single instance of x, and then we're going to use order of operations to solve the question. Our new expression, when we substitute x is equal to 2, reads 3 times 2 squared minus 4 times 2. Using order of operations, we're going to take care of the exponent first. 2 squared is equal to 4. So when we rewrite our expression, let's substitute 2 squared and put in 4. Now our expression reads 3 times 4 minus 4 times 2. Simplify to 12 minus 8, which equals 4. Now let's try another example. This time we see two variables. The example reads, express a over b minus a in terms of x and y if a is equal to 2x and b is equal to 3y. We're going to use the same skills as the last example. This time we're going to do two substitutions. So to start off with, we're going to substitute 2x for a. Every time you see a, we're going to replace it with a 2x. Our new expression reads 2x over b minus 2x. Our next step is to substitute 3y for b. So again, every single time you see the variable b, we're going to replace it with 3y. Our expression now reads 2x over 3y minus 2x. Our last step is to simplify if necessary. But take a look at this expression. There's really nothing that we can do to simplify it further, so we're done. Now that we've gone through a few examples, I'm going to give you a chance to try a few exercises on your own. Take a few moments to try the following exercises, and when you're finished, we'll put up the answers and go through a few examples together. Okay, time's up. Go ahead and check your answers. All right, now let's go ahead and tackle number 1. Number 1 gives us 2x plus 4y plus 7x minus 6y, and the question asks us to simplify the expression. When we're trying to simplify an algebraic expression that contains more than one variable, you want to remember that you can only combine like terms. So x's must be added to other x's, y's must be added to y's, etc. So in this sequence, we have 2x that we can add to 7x, which equals 9x. The 4y we can add to the negative 6y, which becomes negative 2y. So our final expression reads 9x minus 2y. Now let's take a look at number 3. The expression in example 3 contains parentheses. We see the quantity of 3a plus 6b minus the quantity of 7a plus 4b. Now, you'll remember that your acronym for order of operations tells you to evaluate parentheses first. But if you look at the operation inside the parentheses, we can't combine those terms because they're not like terms. In this situation, what you want to do is make sure that you subtract the second quantity fully from the first quantity. The way that we make sure of that mathematically is by distributing that subtraction sign. So take away the parentheses, your expression is now going to read 3a plus 6b minus 7a minus 4b, because that entire quantity must be subtracted from the first quantity. Now that we've distributed the subtraction sign, we can go through and again combine like terms. 3a minus 7a is minus 4a, and 6b minus 4b is 2b. So our new expression reads 2b minus 4a. Now on test day, you may see an answer choice that looks slightly different than what we have down on our scratch paper. Remember that if this does occur, try factoring out a common term in order to rearrange the way your answer looks. In this case, we could factor out a 2, which would leave us with 2 times the quantity of b minus 2a. We haven't changed the expression at all. We've merely manipulated it and put it in a different format. Let's take a look at example number 5. We're given x squared plus y minus 3x squared plus 4y. Notice that our x terms have exponents. When you're looking to combine like terms, you want the exponents to match in order to verify that they're like terms. In this case, they do. So we can simplify x squared and negative 3x squared to minus 2x squared. Adding the y terms, y plus 4y, we get 5y. So our simplified expression is 5y minus 2x squared. Let's take a look at one more example. Number 8. In this set, we are to evaluate the following expressions using x equals 2 and y equals 5. The expression that we're given for example 8 is 9x minus 4y plus x over 2. Because we're given actual values for x and y, we can substitute those values in and solve accordingly. So rewrite the expression substituting in x equals 2 and y equals 5. We get 9 times 2 minus 4 times 5 plus 2 over 2. Remember to follow the order of operations when you evaluate this expression. First we'll multiply. 9 times 2 is 18. 4 times 5 is 20. Then we'll divide. 2 divided by 2 equals 1. So our expression now reads 18 minus 20 plus 1, which adds up to negative 1. Now that you've gotten a chance to try some exercises, let's go ahead and try a test question. Number 11 says, what is the value of the expression x squared plus xy plus y squared when x equals negative 2 and y equals 2? Again, just like the previous exercises that we've looked at, we're going to take those two values and substitute them in every single time we see an x or a y. So rewriting our expression, it looks like negative 2 squared plus negative 2 times positive 2 plus 2 squared. In this example, because one of the values given is a negative number, you're going to want to be careful to make sure that you always write down the negative and that you evaluate accurately. So starting off with our exponents. So our first term, negative 2 squared, will equal 4. Remember that when you square a negative number, the result is going to be positive because those two negative signs are going to cancel out. The next term, negative 2 times 2, simplifies to negative 4. And our last term, 2 squared, simplifies to 4. Add all three of those terms up, 4 minus 4 plus 4, and we get a value of 4, which matches up with answer choice D.